Let's see some problem related to electric field. Here there are four graphs given. We have to identify the correct graph between electric field due to a point charge versus distance. So if there is a point charge q in space, uh, it produces electric field everywhere, and we have a point P at r distance from the source charge. Now at point P, the electric field can be written as 1 by 4 pi epsilon naught q divided by r squared. So if you see E is proportional to 1 over r squared, so the correct graph is B. So here only E decreases as 1 over r squared. Let's move on to the next question. Here there are two charges plus 5 microcoulomb and plus 10 microcoulomb are placed at distance 20 centimeter apart. 5 microcoulomb and then plus 10 microcoulomb. The distance is actually between them is 20 centimeter, so it's 0.2 meter. Now the question is, what is the electric field at the midpoint? So let's take this P is the midpoint. At point P, the electric field due to plus 5 microcoulomb, we can take it as here it will be in this direction, because this is due to 5 microcoulomb, because if you place a unit positive charge here, then it's going to repel that test charge, so it should be along this direction. And now the electric field due to the 10 microcoulomb charge at point P should be also a repulsive one, so it will be 10. Electric field due to 10 microcoulomb will also be in the opposite directions. They are in opposite directions, but they are not equal. So let's find out what is the electric field due to point charge plus 5 first. So it will be E. We are going to find out the magnitude of the electric field. That's what is asked here. So let's find out this 1 by 4 pi epsilon naught. 5 microcoulomb, 5 into 10 power minus 6 divided by the distance of a P from 5 microcoulomb is half of this, that is 10 centimeter. That is 10 centimeter means it's actually 0.1 meter, so meter squared. Now write the same thing for the electric field due to the 10 microcoulomb. So 1 by 4 pi epsilon naught, 5 here, 10 into 10 power minus 6 divided by, once again the distance of P from 10 microcoulomb is 0.1 whole squared. Now what we have to do is we have to take the difference between these two, because we know they are opposite in opposite direction. So we have to take the difference. So it will be 1 by 4 pi epsilon naught if you take it out, and we can also take out 10 power minus 6 divided by 0.1 whole squared, and then we can write this as 10 minus 5. So that will be the total electric field at point P. 1 by 4 pi epsilon naught can be written as 9 into 10 power 9, 10 power minus 6 divided by 10 power minus 2. Here 10 minus 5 will become 5. So we have a 45 into 10 power 9 minus 6 plus 2. This gives you 45 into 10 power 11 minus 6 is 5. And we can write this as 4.5 into 10 power 6 Newton per coulomb. This is the electric field, total electric field. So the right answer is option 1, option A here. So 4.5 into 10 power 6 Newton per Coulomb. And it is towards plus or towards plus 5 microcoulomb or plus 10 microcoulomb. No, it should be towards, the resultant is towards 10 microcoulomb. So option C is the right answer. Now let's see the next question. Very similar to it, but here we are going to find out at what point the electric intensity is zero. So here once again we have 10 microcoulomb plus 10 microcoulomb plus 40 microcoulomb. Two charges are separated by 90 centimeter here, and we have to find out at some point P where the electric field equals zero. So let's take this point from 10 microcoulomb, because here they have mentioned at what distance from 10 microcoulomb the electric field is zero. So let's take this as x and the remaining distance as 90. mm, this is centimeters, so we have to convert into meter. So it is 0.9 minus x distance. And now the we have to find out the electric field at this point. So the electric field between the two like electric field at point P due to 10 microcoulomb will be acting this way, and electric field due to 40 microcoulomb at in this way. So they both are equal and they should be zero, sorry, they should be equal and opposite, so that the total electric field is zero at point P, and we have to find out what is x. So let's write E electric field due to 10 microcoulomb as 1 by 4 pi epsilon naught 10 microcoulomb, 10 into 10 power minus 6, divided by the distance of a point P from 10 microcoulomb is x, so it's x squared. Now write the same way here, E due to 40 microcoulomb equals 1 by 4 pi epsilon naught 40 into 10 power minus 6 divided by the distance of point P from 40 microcoulomb is 0.9 minus x whole squared. Now we have to equate these two to find out the point P where electric field is a zero. So when we equate these two, the 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught will go away. We'll write this as 10 into 10 power minus 6 divided by x squared equals 40 into 10 power minus 6 divided by 0.9 minus x whole squared. So even there's a 10 power minus 6, 10 power minus 6 will go away, and we will have this also. Then we can write this as 1 over x squared equals 4 divided by 0.9 minus x whole squared. Let's solve this for x. We can write this as x squared equals, it means like 4x squared equals 0.9 minus x whole squared. Let's take the square root everywhere on both the sides. So we have 2x equals 0.9 minus x. 2x plus x equals 0.9. So 3x gives you 0.9, x equals 0.9 divided by 3 equals 0.9 meter. That's all. We have found out the distance of a point P. I'm sorry. The distance of point P from 10 microcoulomb is now 0.3 meter. That's it. Thank you.